For centuries, the great deserts of northern China have been a powerful and relentless force. The story of these deserts is woven deep into the history of the region, shaping the lives, cultures, and destinies of those who have lived on their shifting edges. The Gobi Desert, a vast and arid expanse, has been slowly creeping southward, swallowing fertile lands and threatening the livelihoods of millions. For generations, farmers and herders have watched as the sands advanced, year after year, consuming villages and fields that once flourished. This process, known as desertification, turns once productive soil into barren sand. It is a slow, almost invisible disaster, one that has haunted northern China for centuries. The wind, with nothing to stop it, picks up this loose sand and dust, carrying it for thousands of miles. These winds have shaped not only the land, but the very way people have lived, forcing them to adapt or abandon their homes. These immense sandstorms, sometimes called the Yellow Dragon, would descend upon villages and even major cities like Beijing, choking the air, burying homes, and destroying crops. In the spring, the sky would turn an ominous yellow, and the sun would vanish behind a wall of dust. It was a slow-motion natural disaster, a crisis that was growing worse with each passing year. The land was not only being lost to the desert, but the very air was becoming unbreathable. The causes of this expanding desert were complex, stemming from a combination of natural climate patterns and human activities. Centuries of drought, shifting monsoons, and the relentless pressure of a growing population all played a role. Overgrazing by livestock stripped the land of its protective grasses, leaving the soil exposed. As herds grew larger, the fragile grasslands could no longer recover, and the desert crept ever closer. Deforestation, where trees were cut down for fuel and timber, removed the natural windbreaks that held the earth in place. Without these barriers, the wind gained strength, and the soil was left defenseless. Improper farming and irrigation techniques further depleted the soil of its nutrients and water, making it more vulnerable to the dry, relentless winds. The land, once rich and productive, became a battleground between man and nature. China's leaders realized that they were facing an environmental catastrophe. The threat was not just to the land, but to the nation's food security, economic stability, and even its social fabric. The government understood that bold action was needed, something on a scale never before attempted. The idea that was born from this crisis was as ambitious as the Great Wall of ancient times. Just as the old wall had protected the heartland from invaders, a new kind of wall would be needed to defend against the advancing sands. Instead of stone and brick, this new wall would be made of living trees. It would be a living barrier, rooted in the earth, growing stronger with each passing year. The project, officially called the 3 North Shelter Forest Program, became known to the world as the Great Green Wall. It was a vision that captured the imagination of a nation. Its purpose was simple in concept, but enormous in scale: to plant a massive belt of trees along the edge of the northern deserts. The goal was to create a barrier that would hold back the sands and reclaim the land for future generations. This living barrier was intended to act as a shield. It would slow the fierce winds, anchor the shifting sands, and over time help to restore the damaged ecosystem, creating a new line of defense against the relentless march of the desert. This was not just an environmental project, it was a declaration of war against desertification. The government called upon the people to join in a national effort, appealing to their sense of duty and pride. The vision was to create a green buffer zone that would stretch across the entire northern part of the country, a testament to human will and ingenuity in the face of a formidable natural challenge. The government mobilized millions of people, from soldiers to students to ordinary citizens, in a national effort to plant these trees. Early public reaction was a mix of skepticism and hope. Some doubted the project's scale, while others saw it as a patriotic duty. It was a project that would span decades, a long-term commitment to heal the land and secure a more stable future for the generations to come. The early years were marked by trial and error, but the determination to succeed never wavered. The hope was that this green fortress would not only stop the desert, but begin to push it back. In the face of overwhelming odds, China's Great Green Wall became a symbol of resilience, unity, and the enduring power of collective action. The scale of the Great Green Wall project is truly staggering, an environmental initiative so vast it stretches the imagination. Launched in 1978, the project set out to create a living barrier of trees nearly 3,000 miles long, spanning from the arid deserts of Xinjiang in the west to the lush plains of Heilongjiang in the east. This immense green belt cuts across 11 provinces, covering an area larger than many entire countries. The ambition was to increase China's forest cover from just 5% to 15% by the year 2050, transforming millions of hectares of barren land into thriving woodland. Achieving this vision required an almost unimaginable number of trees. Over the past 4 decades, more than 66 billion trees have been planted, according to official reports, a figure that continues to rise every year. The logistics behind such a massive operation are mind-boggling. Teams of workers have traversed some of the harshest and most remote landscapes on Earth, planting saplings by hand in areas where machinery cannot reach. The methods used to plant these billions of saplings have been as varied as the terrain itself, adapting to deserts, grasslands, and mountains. In some regions, teams have painstakingly planted trees by hand, digging holes in dry, sandy soil and carefully placing each sapling to maximize its chance of survival. In more remote or challenging locations, the project has relied on technological innovation. Specialized machinery has been developed to plant trees at scale, allowing for rapid progress in areas where manual labor alone would be too slow. One of the most remarkable innovations is aerial seeding. Airplanes fly over vast stretches of barren land, releasing millions of seeds encased in nutrient-rich soil pods. This technique enables the rapid afforestation of areas that are otherwise inaccessible. The combination of human effort and advanced technology has been essential to the project's success, demonstrating a relentless commitment to transforming the landscape. The primary goal of this massive planting effort was to create a windbreak, a living shield to slow the fierce winds blowing from the Gobi Desert and protect the fertile lands to the south. By reducing wind speed, the trees help prevent the loss of precious topsoil and reduce the frequency and severity of sandstorms that have long plagued northern China. The root systems of these forests bind the soil, making it more resistant to erosion and helping to stabilize the land. The Great Green Wall is not just about planting trees. It is about re-engineering entire ecosystems on a continental scale, turning deserts into forests, and transforming the environment for generations to come. This monumental effort stands as a symbol of China's determination to confront environmental challenges head-on and reshape its own destiny. The project has drawn international attention, with many countries and organizations recognizing it as one of the most ambitious afforestation efforts in history. The image of a green line holding back the encroaching desert has become a powerful symbol of hope and resilience. For years, the Great Green Wall was celebrated as a resounding success, a model for other nations facing similar environmental threats. The statistics are impressive, and the visual transformation in many regions is undeniable. Yet beneath the surface of this green dream, significant challenges have begun to emerge, threatening the long-term sustainability of the project. When compared internationally, China's Great Green Wall dwarfs similar projects, such as Africa's Great Green Wall Initiative, both in length and in the sheer number of trees planted. The logistical complexity, technological advancements, and scale of human mobilization set it apart as the largest and most ambitious afforestation project the world has ever seen. One of the most significant and fundamental problems with the Great Green Wall was the method of its creation. In the rush to plant as many trees as possible, the project largely relied on a strategy known as monoculture. This means planting vast areas with only a single species of tree, most often fast-growing poplars that were chosen for their ability to survive in dry conditions. While this approach made the planting process simpler and more efficient, it created an artificial forest that was ecologically fragile and deeply unhealthy. A natural forest is a complex, diverse ecosystem with many different types of trees, shrubs, and undergrowth, all working together. This diversity supports a wide range of animal and plant life, creating a resilient system that can withstand disease, pests, and environmental changes. The Great Green Wall, in many places, was more like a tree farm than a true forest. This lack of biodiversity created a host of problems. Scientific studies have shown that monoculture plantations support far fewer species of birds, insects, and mammals compared to natural forests. A forest with only one type of tree is extremely vulnerable. In 2012, a study by the Chinese Academy of Sciences found that poplar monocultures in northern China suffered repeated outbreaks of pests and diseases, leading to widespread die-offs. If a disease or a specific pest that targets that one species arrives, it can sweep through the entire forest with devastating speed, as there are no other types of trees to stop its spread. This phenomenon has been observed not only in China, but also in other countries. For example, the Irish potato famine and the American chestnut blight both illustrate the dangers of relying on a single species. Furthermore, these monoculture forests did not create a healthy ecosystem on the ground. The lack of undergrowth and ground cover meant that the soil remained exposed and vulnerable. The dense canopy of the poplar trees often created so much shade that nothing could grow underneath them. This is a common problem in monoculture plantations, as confirmed by a 2015 study published in the journal Forest Ecology and Management. This left the forest floor bare, with exposed soil that was still susceptible to erosion from water runoff, defeating one of the primary goals of the project. In some areas, erosion actually increased after monoculture plantations were established. The choice of tree species also led to another critical issue: water. While the poplars were chosen for their hardiness, they still required a great deal of water to survive and grow. In fact, research from Beijing Forestry University found that poplar plantations in arid regions consumed more water than the native vegetation they replaced. In the arid and semi-arid regions of northern China, water is an incredibly scarce resource. The introduction of thirsty tree species only intensified competition for this limited supply. The newly planted trees began to draw heavily on the underground water table, like countless straws sucking from a limited supply. Over time, this led to a significant drop in groundwater levels, as documented in a 2018 report by the Chinese Ministry of Water Resources. In many areas, the trees initially thrived, but after a few years, they had depleted the groundwater to such an extent that they began to wither and die. This cycle of boom and bust has been observed in monoculture plantations around the world, from eucalyptus in Brazil to pine in South Africa. This led to a shockingly high failure rate, with some estimates suggesting that up to 85% of the trees planted in certain areas did not survive in the long term. A 2019 review by the International Union of Forest Research Organizations highlighted similar failures in monoculture projects worldwide. The project was based on a flawed assumption that simply planting trees would create a forest. Experts like Dr. Liu Ming, a leading Chinese ecologist, have warned that without biodiversity, these plantations cannot function as real forests. It overlooked the intricate web of life that makes a natural forest resilient and self-sustaining. In a healthy forest, different species interact in complex ways, supporting soil health, water retention, and pest control. The Great Green Wall was being planted in a region where forests do not naturally grow, far from the coastal areas that provide the moisture needed to support such ecosystems. According to a 2020 study by the Chinese Meteorological Administration, the climate in these regions is fundamentally unsuitable for large-scale forests, Instead of helping to create a more balanced environment, in some cases the trees were actually making the land drier and more barren. This paradox has been observed in similar projects in Central Asia and parts of Africa, where monoculture plantations have sometimes accelerated desertification. The dream of a green barrier was colliding with the harsh reality of ecology, revealing a deep misunderstanding of how nature truly works. As experts around the world have concluded, true reforestation requires diversity, local adaptation, and respect for the complex systems that sustain life. The inherent weakness of the monoculture approach was exposed in a dramatic and catastrophic event, one that would shake the very foundation of the Great Green Wall project. In one region, a massive section of the Great Green Wall, stretching for hundreds of miles, consisted almost entirely of a single species, the hybrid poplar, Populus X canadensis. For years, this green belt stood as a supposed success story, a testament to human determination and engineering. But then a tiny enemy appeared, the Asian long-horned beetle, Anoplophora glabripennis, a notorious wood-boring insect native to East Asia. This particular beetle has a voracious appetite for poplar trees as well as willows, elms and maples, but in this case, the poplars were the main target. In a diverse natural forest, the beetles would have been kept in check by natural predators such as woodpeckers, parasitic wasps, and the presence of other tree species that they could not eat. But in this artificial forest, they found an endless, uninterrupted buffet, row after row of identical vulnerable trees. The beetle infestation spread like wildfire. Adult beetles chewed through bark to lay their eggs, and the larvae burrowed deep into the wood, disrupting the flow of water and nutrients. With no other tree species to act as a barrier and few natural enemies to control their numbers, the beetle population exploded. The infestation was relentless, with entire groves succumbing in a single season. The beetles moved from tree to tree, laying their eggs and devouring the wood from within. The larvae, pale and voracious, hollowed out the trunks, killing the poplars with ruthless efficiency. The result was an ecological disaster on an unimaginable scale. The monoculture had created the perfect conditions for a single pest to wreak havoc. In what seemed like an instant, an estimated 1 billion trees were wiped out. The devastation was visible from the air. Once green corridors, now grey and lifeless. An entire section of the Great Green Wall, representing years of work and immense investment, was destroyed. The loss was not just visual, but ecological and economic. The green leaves vanished, leaving behind a silent, skeletal forest of dead and dying trees. The soil, once anchored by roots, began to erode. This event was a brutal but important lesson. The collapse of the poplar forests triggered a cascade of ecological consequences. It demonstrated in the starkest possible terms the profound risks of relying on a single species. The loss of tree cover led to increased wind erosion, dust storms, and the return of desertification in some areas. Nature's strength lies in its diversity. Without it, the ecosystem was left defenseless. A mixed forest, with many different types of plants and animals, has built-in resilience. The presence of multiple species creates natural checks and balances. If one species is attacked by a pest or disease, others survive, and the ecosystem as a whole can endure and recover. But here, the lack of diversity meant total collapse. The Great Green Wall, however, had been built without this natural insurance policy. The monoculture was a gamble, and it failed. It was a fragile man-made system that lacked the complexity and robustness of a true forest. And when it was tested, it collapsed. The beetle infestation was a wake-up call. The beetle disaster forced scientists and policymakers to re-evaluate the entire strategy of the project. The government responded with urgency. Teams of forestry experts and entomologists were dispatched to the affected regions. They surveyed the damage, collected beetle specimens, and studied the life cycle of Anoplophora glabripennis in detail. Emergency measures were put in place. Infected trees were cut down and burned to prevent further spread. Quarantine zones were established, and movement of timber was strictly controlled. The government also began to promote the planting of mixed forests, introducing native species such as Chinese pine, Mongolian oak, and various shrubs to increase biodiversity and resilience. The image of 1 billion dead trees served as a powerful warning against trying to impose an overly simplistic solution on a complex environmental problem. The scale of the loss was a sobering reminder of nature's unpredictability. The dream of a simple green line was fading, and the need for a more nuanced, ecologically minded approach was becoming impossible to ignore. The government's response marked a turning point in the project's philosophy. The Great Green Wall had to evolve or risk complete failure. The lesson of the beetle infestation would shape the future of reforestation in China for years to come. As the limitations of the massive tree planting project became increasingly apparent, especially in the face of persistent soil degradation and high sapling mortality, a number of scientists and ecologists began searching for new, innovative solutions that could address the root of the problem, literally, the soil itself. One of the most intriguing and honestly unconventional ideas to emerge was the burrowing animal hypothesis, a theory that challenged conventional reforestation wisdom. This hypothesis proposed that the introduction or encouragement of certain small burrowing animals, native to the region, could help heal the damaged soil and restore a more functional ecosystem. The focus shifted from what was happening above the ground with the trees to what could be improved below the ground in the soil itself, a realm often overlooked in large-scale restoration projects. The heroes of this new strategy would not be planters with shovels, but tiny creatures like gerbils and jerboas, species that have evolved to thrive in these harsh, arid environments. The logic behind this hypothesis is rooted in the concept of ecosystem engineers, species that actively shape and modify their environment. These animals, through their digging and foraging, create better conditions for themselves and for countless other organisms. By disturbing the soil, they enable new plants to take root and flourish where previously only barren ground existed. Burrowing animals are, frankly, master ecosystem engineers. As they dig their extensive networks of tunnels, they perform several vital functions, mixing soil layers, aerating the ground, and improving water infiltration. By bringing nutrient-rich soil from deeper layers up to the surface, they help replenish the topsoil that is essential for plant growth. This process not only improves soil fertility, but also allows air and, most importantly, water to penetrate more easily, instead of just running off the hard, compacted surface. The improved soil structure could be a lifeline for struggling tree saplings and other vegetation. Furthermore, these small animals play a crucial role in processing organic matter. As they forage for seeds and plants, their waste products and any uneaten organic material left in their burrows decompose, enriching the soil with vital nutrients. Their digging activity also helps to bury seeds, protecting them from the harsh sun and wind, and creating ideal conditions for germination. In essence, these animals could act as tiny, tireless gardeners, helping to kickstart the natural processes of soil regeneration that the monoculture forests had failed to achieve. The idea was to work with nature's own mechanics, rather than against them. The proposed species for this experiment, such as the Mongolian gerbil and the five-toed jerboa, were carefully considered for their ecological roles and native status. These animals are native to the deserts and steppes of northern China, meaning they are already perfectly adapted to the arid climate and harsh conditions. They would not be an invasive species, but a reintroduction of a natural component of the local ecosystem. The hypothesis was that by bringing back these key players, it might be possible to repair the broken soil food web and create a healthier foundation for a more diverse and resilient plant community. But how did this theory hold up in practice? To answer this, several experimental plots were established in the arid regions of northern China. In these controlled environments, researchers introduced populations of Mongolian gerbils and five-toed jerboas, monitoring changes in soil quality, plant diversity, and sapling survival rates. The results were promising. Over the course of several seasons, plots with active burrowing animal populations showed significant improvements in soil aeration, moisture retention, and nutrient content. Saplings planted near burrow networks had higher survival rates, and a greater diversity of grasses and shrubs began to appear, indicating a more robust ecosystem. To gain further insight, we spoke with Dr. Li Wei, a leading soil ecologist, who explained, as Dr. Li Wei, the burrowing animal hypothesis is grounded in decades of ecological research. These animals are not pests, but essential partners in restoring degraded land. Their activities create microhabitats, improve soil structure, and facilitate plant establishment. Dr. Zhang Ming, another expert in arid land restoration, added, as Dr. Zhang Ming, our experiments show that reintroducing native burrowing mammals can accelerate the recovery of soil health and biodiversity. It's a strategy that works with the natural processes of the ecosystem. The evidence suggests that by harnessing the power of these small but mighty animals, it may be possible to restore degraded landscapes more effectively than with trees alone. The burrowing animal hypothesis offers a new hope for China's Great Green Wall, one that is rooted in the wisdom of nature and the resilience of its smallest inhabitants. By restoring the soil food web and supporting a diverse plant community, these animals could help transform barren deserts into thriving, resilient ecosystems, side by side with the trees. The concept of using burrowing animals as ecosystem engineers is rooted in solid ecological theory, but it is also accompanied by a host of significant risks that demand careful scrutiny and respect for the complexity of nature. Introducing any species, even one native to the region, into a new or heavily modified environment is a delicate and potentially dangerous operation. The ecological balance of an area is the result of countless interactions developed over millennia, and even small changes can have cascading, unpredictable effects. The Great Green Wall, for all its ambition, is not a natural ecosystem. It is an artificial construct, lacking the intricate web of relationships that stabilize wild environments. This makes the outcome of any intervention especially uncertain. One of the most pressing concerns is the potential for a population explosion. When animals are introduced into a new environment without their full suite of natural predators, their numbers can grow rapidly and uncontrollably. In their native habitats, populations of gerbils and jerboas are kept in check by a balance of food availability and predation from animals such as foxes, eagles, and snakes. This balance is essential for ecosystem health. However, in the artificial forests of the Great Green Wall, many of these natural predators are absent or present only in very low numbers, disrupting the natural checks and balances. Without these predators, rodent populations could experience unchecked growth, leading to overgrazing, soil degradation, and the destruction of young plants. What begins as a small beneficial group of soil-mixing animals could quickly escalate into a massive swarm, consuming vegetation, destabilizing soil, and undermining the very ecosystem they were meant to help. Instead of fostering plant growth, these animals could end up devouring seeds and saplings, preventing regeneration and causing more harm than good. If left unchecked, rodent populations could spill over into nearby agricultural lands, leading to crop destruction and sparking new conflicts between conservation efforts and local farmers. Another major risk is the spread of disease. Rodents and other small mammals are known carriers of parasites and viruses, some of which can be transmitted to other wildlife, livestock, or even humans. Any animal population, especially one that grows rapidly, can become a reservoir for disease. Parasites such as ticks and fleas, as well as viral and bacterial pathogens, can spread quickly in dense populations. Without rigorous health screening and quarantine protocols, introducing animals into the vulnerable monoculture of the Great Green Wall could inadvertently introduce new diseases with potentially devastating consequences. In a diverse natural ecosystem, disease outbreaks may be contained by the variety of species and ecological niches. In a monoculture, however, a single pathogen can sweep through the population, killing trees, animals, and further destabilizing the ecosystem. The very intervention intended to restore the ecosystem could, if mishandled, deliver a fatal blow, setting back restoration efforts by years or even decades. History is filled with cautionary tales of well-intentioned animal introductions gone wrong. The introduction of rabbits to Australia, for example, led to ecological disaster, as did the release of cane toads and other species in various parts of the world. These historical precedents show that even experts can underestimate the risks, and that the consequences of introducing a new species can be both severe and irreversible. Many ecologists and conservationists warn that the introduction of animals into artificial or heavily altered environments should only be considered as a last resort and only after exhaustive study, risk assessment, and long-term monitoring plans are in place. Even if the introduction were to go perfectly, it might not address the fundamental issues facing the Great Green Wall, such as water scarcity and poor soil quality. These animals cannot create water or alter the climate. They cannot change the fact that the forests were planted in a region that is fundamentally too arid to support them naturally. At best, their positive impact might be small and localized, offering only minor improvements that fail to address the core flaws of the project. At worst, the introduction could accelerate ecosystem collapse, compounding existing problems and creating new ones. The collapse of the ecosystem could be hastened by overpopulation, disease, and the destruction of vegetation, leaving behind a barren and degraded landscape. For all these reasons, the idea of introducing burrowing animals to the Great Green Wall remains a theoretical proposal, not an official policy. It serves as a reminder of the immense caution required when humans attempt to manage or manipulate nature, and the importance of learning from past mistakes before taking bold new steps. The challenge that China is addressing with its Great Green Wall is part of a much larger global struggle. Desertification is a worldwide crisis, a slow-moving environmental disaster that affects every continent except Antarctica. According to the United Nations, nearly a quarter of the Earth's land surface is threatened by desertification, impacting both the environment and human societies. This is not simply the natural growth of deserts, but the result of land degradation in arid, semi-arid and dry, subhumid areas, driven mainly by human activities and climate change. Fertile land is turning to dust, threatening the food security and livelihoods of billions of people worldwide. The statistics are sobering. Each year, the world loses an area of productive land larger than the country of Ireland, over 29 million acres, to desertification and drought. Nearly 1/6 of the world's population, well over 1 billion people, live in areas vulnerable to desertification. The consequences are severe: food shortages, economic hardship, and forced migration. Over the last 40 years, the world has lost about 1/3 of its arable land to erosion and degradation, a trend that continues to accelerate. Every year, humanity loses more and more fertile land, putting increasing pressure on food supplies and local economies. This loss of productive land can lead to poverty, social instability, and mass migration as people are forced to leave their homes in search of more hospitable environments. The main causes of desertification are well known: deforestation, overgrazing, unsustainable agriculture, and the intensifying effects of climate change. Deforestation removes the trees that protect soil and regulate local climate, while overgrazing by livestock strips the land of vegetation, leaving it exposed to erosion. Overgrazing, especially in fragile environments, accelerates the loss of plant cover and soil fertility. Poor agricultural practices, such as excessive tilling and improper irrigation, can deplete soil nutrients and cause salinization, making the land unproductive. All of these pressures are being intensified by climate change, which brings more frequent and severe droughts to many regions. From the Sahel in Africa to Central Asia, from the Australian outback to parts of North and South America, communities are facing the same threats as those in China. They watch their wells run dry, their crops fail, and their land turn to sand. Desertification is a complex problem, intertwining environmental degradation with social and economic challenges. The health of our planet's land is directly linked to the stability and prosperity of human civilization. The fight against desertification is a global effort. International organizations, governments, and local communities are working together to restore degraded land, share knowledge, and develop sustainable practices. Initiatives like the United Nations Convention to Combat Desertification, the African Great Green Wall, and regional projects in Central Asia and the Americas are making progress, though the scale of the challenge remains immense. These efforts offer valuable lessons for China and the world: the importance of community involvement, the need for science-based solutions, and the power of international cooperation. By learning from global successes and failures, China can refine its own strategies and contribute to a worldwide movement to halt and reverse desertification. The struggle against the spread of deserts is not just China's fight. It is a shared responsibility and a test of our collective will to secure the future of our planet. In China, the statistics of desertification are particularly stark and have been a driving force behind the nation's environmental policies for decades. The problem is vast, affecting a huge portion of the country and touching the lives of men, children, and the elderly in countless communities. It is estimated that desertification impacts over a third of China's total land area, a territory that is home to nearly 400 million people. This is not a distant, abstract problem. It is a daily reality that directly affects the lives and livelihoods of a population larger than that of the United States. The encroaching sands of the Gobi and Taklamakan deserts are a constant threat, burying infrastructure, agricultural land, and entire villages. The economic costs of this environmental crisis are immense, with men and the elderly often bearing the brunt of lost income and livelihoods. Every year, the direct economic losses from desertification in China are measured in the tens of billions of dollars. This includes the loss of productive farmland, the cost of cleaning up sandstorms in major urban centers, and the damage to roads, railways, and communication lines, often repaired by local men and boys. For the farmers and herders living on the front lines of this battle, the impact is personal and devastating, especially for men who must provide for their families, and for the elderly, who have seen their land change beyond recognition. They watch as their pastures degrade, unable to support their livestock, and as their fields, once fertile, become barren and unproductive. This process forces many to abandon their ancestral homes, becoming ecological migrants in their own country. Elderly men who have lived their entire lives in these villages are often the last to leave, while children must adapt to new and unfamiliar environments. The most dramatic and visible manifestation of this problem is the sandstorms, which disrupt daily life for everyone, but especially for the young and the old. These terrifying events, known as the Yellow Dragon, occur when strong winds pick up loose sand and dust from the degraded lands of the north and west. These massive clouds of dust can travel for thousands of miles, reaching all the way to the capital, Beijing, and sometimes even crossing the Pacific Ocean to North America. When these storms hit, they can reduce visibility to near zero, shut down airports and highways, and cause serious respiratory problems for the population, especially for children and the elderly, who are most vulnerable to the choking dust. They are a powerful, suffocating reminder of the ecological imbalance that has taken hold in the region. leaving lasting scars on the health and well-being of local communities. The Chinese government recognized early on that this was not just an environmental issue, but a threat to national stability and development. The fight against desertification was framed as a crucial part of the country's modernization efforts, with men and boys often participating in reforestation and land restoration projects. The Great Green Wall was the first and most famous response to this threat, a grand gesture to hold back the tide of sand. While the project has faced many challenges and criticisms, its very existence underscores the severity of the problem. The relentless expansion of the desert posed an existential threat that demanded a response of equal magnitude, setting the stage for decades of environmental engineering on a scale never seen before, one that continues to shape the lives of men, children, and the elderly across northern China. After decades of trial, error, and reflection on the limitations of the original Great Green Wall, China is now embracing a new era of land restoration, one that is guided by science, policy reform, and a deeper understanding of ecological systems. The outdated model of planting vast single-species forests is being phased out. In its place, new projects are emerging that emphasize biodiversity, ecosystem resilience, and the integration of native species. Environmental planners and forestry experts now recognize that true restoration means rebuilding entire ecosystems, not just increasing tree cover. The focus has shifted to creating self-sustaining, multi-layered forests that can withstand environmental stress. This new approach is rooted in ecological intelligence. Scientists are using advanced monitoring equipment and data analysis to track forest health, soil quality, and biodiversity, allowing for adaptive management and evidence-based decision-making. Across China, pilot projects are testing these strategies on the ground. These sites serve as living laboratories where new planting techniques, species combinations, and management practices are evaluated for their effectiveness. In southwest China, for example, a major project in partnership with international conservation organizations is restoring thousands of acres with a carefully curated mix of native trees. This collaboration brings together global expertise and local knowledge. These new forests are designed to mimic natural diversity, incorporating conifers, broadleaf trees, and bamboo. This complexity supports a wider range of plant and animal life. The result is a more stable and resilient habitat, less vulnerable to pests, disease, and climate extremes. These restored forests provide essential habitat for wildlife, helping to rebuild food webs and restore ecological balance. In Sichuan province, a region renowned for its biodiversity and as the home of the giant panda, another ambitious project is underway to restore a critical biological hotspot. Here the focus is on reintroducing native species such as almond pine, China cedar, and various spruces, chosen for their ecological roles and adaptability. These projects are supported by long-term management plans, including regular monitoring, maintenance, and adaptive interventions to ensure the forests mature into healthy, functioning ecosystems. The benefits are far-reaching. Restored forests absorb thousands of tons of greenhouse gases each year, protect vital watersheds, and reduce soil erosion, directly supporting local communities and agriculture. This holistic vision treats forests as living systems, providing clean water, air, and habitat rather than just as barriers against sand and wind. Underpinning this transformation are new national policies. The Chinese government has introduced stricter guidelines for species selection, ecological zoning, and post-planting care. Funding is now directed toward projects that demonstrate measurable ecological benefits, not just tree numbers. Old monoculture plantations are being rehabilitated, with native species gradually introduced to replace less resilient trees. This patient, knowledge-driven approach is informed by the latest ecological research and field data. Scientists are studying natural forest patterns, soil microbiomes, and animal-plant interactions to guide restoration. The goal is to let nature lead, with human intervention supporting rather than dominating the process. Restoration now includes planting shrubs and grasses alongside trees, creating layered habitats that foster greater biodiversity and speed up ecosystem recovery. Looking ahead, China's restoration strategy is set to expand. New pilot projects are being launched in arid and semi-arid regions, with a focus on climate adaptation and community involvement. The government is investing in research, training, and international cooperation to refine techniques and share lessons learned. The future of China's Great Green Wall lies in continuous learning, innovation, and collaboration. By combining traditional knowledge with cutting-edge science, and by involving local communities and experts, China is charting a new, more hopeful path for ecological restoration. The story of the Great Green Wall is no longer just about planting trees. It is a story of transformation, of learning from the past, embracing complexity, and working with nature to restore balance and resilience to the land. As China's restoration strategy evolves, technology has become a powerful ally in the battle against desertification. Today, the Great Green Wall is not just a feat of human labor. It's a showcase of cutting-edge innovation, transforming barren landscapes into thriving forests. Drones, once reserved for aerial photography, now play a crucial role in large-scale tree planting. These unmanned aerial vehicles soar above the arid land, precisely dropping seed pods in carefully mapped patterns. Each pod contains a mix of seeds, nutrients, and moisture-retaining gel, giving new saplings a better chance of survival in harsh conditions. Drones can cover vast areas far more efficiently than manual labor, allowing for rapid reforestation in regions that are otherwise difficult to access. But planting is only the beginning. Satellite monitoring systems now provide real-time insights into forest health across millions of acres. Using high-resolution imagery and remote sensing technology, scientists can track changes in vegetation cover, soil moisture, and even detect early signs of disease or pest infestations. This constant stream of data enables quick responses to emerging threats and helps guide adaptive management strategies. Water scarcity remains a major challenge in northern China's drylands. To address this, engineers have developed advanced irrigation systems tailored to the needs of young forests. Drip irrigation networks deliver water directly to the roots, minimizing evaporation and waste. Some projects use solar-powered pumps, ensuring a sustainable supply of water even in remote locations. On the ground, soil sensors measure moisture levels, nutrient content, and temperature, feeding data back to central control hubs. This allows forestry teams to fine-tune irrigation schedules and fertilizer use, maximizing tree survival rates while conserving precious resources. Artificial intelligence and machine learning further enhance restoration efforts. Algorithms analyze data from satellites, drones, and ground sensors to identify the best planting sites, predict growth patterns, and optimize species selection. This digital ecosystem ensures that every decision is informed by the latest science and field data. Together, these technological innovations are accelerating the restoration of China's landscapes. By combining human expertise with smart machines and real-time data, the Great Green Wall is becoming more resilient, efficient, and adaptive than ever before. The integration of technology not only increases the scale and speed of reforestation, but also ensures that new forests are healthy, diverse, and sustainable for generations to come. While technology plays a crucial role in the restoration of China's landscapes, the success of the Great Green Wall also relies heavily on the dedication and hard work of local communities and male workers. These individuals are the backbone of this monumental project, carrying out daily tasks that ensure the health and growth of the new forests. The Great Green Wall is not just an ecological initiative, it's a powerful economic engine reshaping entire regions of northern China. Since its inception, the project has generated substantial benefits for agriculture, forestry, and rural development. According to the National Forestry and Grassland Administration, Areas adjacent to the Green Wall have seen agricultural yields increase by up to 15% over the past decade. This is largely due to improved soil quality and reduced wind erosion, creating more stable environments for crops such as corn and wheat. Forestry has also experienced a boom. The total value of timber and non-timber forest products has grown by 30% in project zones since 2010. Expert Dr. Li Wen, an environmental economist, explains, "The expansion of forests has diversified rural incomes. Many local men now work year-round in forest management, harvesting and reforestation, providing stable jobs that didn't exist before." Case studies from Inner Mongolia show remarkable transformations. In the village of Zilin, for example, collective incomes have doubled since the implementation of shelter belts and agroforestry. Local cooperative leader Mr. Zhang shares, "Before the project, our land was barren and yields were low. Now we benefit not only from better crops, but also from sustainable timber sales and increased livestock productivity, thanks to improved pastures. The ripple effects are clear. Rural economies are more resilient, local markets are thriving, and communities have greater resources for infrastructure and education." With ongoing government investment and community involvement, the Great Green Wall is proving to be as much an economic revolution as it is an environmental one. The success of China's Great Green Wall has not gone unnoticed by the rest of the world. As desertification threatens regions from Africa's Sahel to Central Asia, international collaborations have become a cornerstone of the fight against land degradation. Over the past decade, China has actively shared its expertise, hosting joint research projects and technical exchanges with countries including Kazakhstan, Mongolia, and Ethiopia. In 2018, the China-Kazakhstan Joint Laboratory for Desertification Control was established, bringing together teams of scientists and land managers. Their work has focused on adapting China's tree planting techniques to the unique soils and climates of Central Asia. These efforts have led to the successful restoration of over 10,000 hectares of degraded land along the Kazakh border. Technical conferences such as the annual Belt and Road Desertification Control Forum have become vital platforms for exchanging knowledge. Here, Chinese forestry engineers present advances in satellite monitoring and drought-resistant tree species, while delegates from other nations share their own local solutions. Many of these exchanges have resulted in ongoing field trials and the adaptation of Chinese machinery for use in other arid regions. China has also exported its innovative technologies, including remote sensing systems and water-saving irrigation methods, to partners in Africa. In Niger, for example, Chinese consultants have worked alongside local teams to implement shelter belt projects modeled after the Great Green Wall, leading to measurable improvements in soil stability and crop yields. These collaborations are more than just technical assistance. They represent a growing global network committed to reversing desertification. As knowledge and technology flow across borders, China's experience is helping to shape the future of sustainable land management worldwide. The story of the Great Green Wall doesn't end with planting trees. It's an ongoing scientific endeavor. Decades of environmental monitoring and research have been critical to understanding the project's true impact and guiding its evolution. Teams of field workers and scientists regularly visit the shelter belts, collecting soil samples, measuring tree growth and recording biodiversity changes. Remote sensing satellites capture high-resolution images, allowing for precise tracking of vegetation cover, land degradation, and even microclimate shifts over time. On the ground, mobile weather stations and sensor networks provide real-time data on rainfall, wind speed, and soil moisture. These efforts have produced valuable insights. Researchers have documented a steady increase in vegetation density across key regions, with satellite data confirming the stabilization of sand dunes and a reduction in dust storm frequency. Long-term soil studies reveal improvements in organic matter and moisture retention, which have translated into more resilient croplands and rangelands. However, The data also highlight ongoing challenges. Monoculture plantations have shown vulnerabilities to pests and drought, prompting a shift toward more diverse mixings of native species. Scientists are now focusing on optimizing tree combinations, improving water use efficiency, and studying the recovery of local wildlife populations. Looking ahead, the next phase of research will leverage artificial intelligence and big data analytics to predict trends and refine restoration strategies. Drones and autonomous vehicles will expand the reach of field surveys, while genetic studies of drought-resistant plants aim to future-proof the wall against climate change. Through continuous monitoring and adaptive science, the Great Green Wall remains not just a barrier against the desert, but a living laboratory, one where lessons learned today will shape the sustainable landscapes of tomorrow.